going to get started. I'm going to be down here because I think, we're a small crowd, so no need for me to be up there. So welcome, everyone. I hope you're enjoying the event so far. So yeah, let's get this started. I'm going to start with a little disclaimer. So if you happen to have read the description of my talk, and also when I was planning this talk, I proposed it like, let's talk about a fictional project where we go through from this point to this point, and then I thought, I don't think that's very useful to talk about a fictional project, and so I kind of changed it a little bit to talk more about some more relevant and modern stuff. So yeah, if you didn't read the description, then just ignore what I just say and enjoy what I'm gonna say. That's all. All right. So because we're a small crowd, I can talk to you and I can see you all. So are there any of you building any AI applications? Okay. Are you using them? I know it's 2025, so it might be a silly question, but are you using any? Yes, everyone's like, yes, I know. Me too. So because of this reason, I thought it would be useful to share how to go, or like how does authorization works in the sense of building or using an AI application. So that's what we're going to do. But before we jump into that, let me introduce myself. My name is Carla, and I'm a developer advocate at Auth0. I'm also a software engineer, and I've been in the industry for over 10 years. I'm not going to say how many, just over 10 years, so you can find that out. I'm happy to connect on LinkedIn if anyone wants to talk there. I'm also a LinkedIn learning instructor, and I really enjoy good coffee. So if anyone wants to talk about coffee after this talk with me, I'm happy to have that conversation as well. So yeah. This is what happens when I improvise. Okay, so the thing with AI, as you may know, is that it is evolving way too fast. The things that we can do 2 years ago have nothing to do with the things that we could do 1 year ago or even 1 month ago. I don't know if you remember that time when AI images couldn't get hands and fingers right, and everything looked like very weird. And now I get my mom sending me AI-generated videos being like, oh my God, did you see this? And I'm like, that's not real, but to her, it might feel real. All of this to say that it's evolving too fast, and the thing is that security is not evolving as fast. That's just a fact. And I think we can all agree that, at least me personally, every time I see something in the AI world, I'm like, I'm missing out on something because I was trying something else, and now I have to try this new tool. Anyways, everything is going way too fast. And because security isn't evolving too fast, we're still trying to catch up. We're still trying to figure out how to do it. OWASP defined the top 10 LLM risks in an effort to kind of like bring awareness to this. And these are the top 10 for 2025. So we have prompt injection, sensitive information disclosure, supply chain attacks, data model poisoning, improper output handling, excessive agency, so on and so forth. And if you think about it, some of these we can control, some of them we cannot control, but we can definitely take some sort of action in at least the first few of those. And today I want us to focus particularly on sensitive information disclosure. And so when can this happen? So imagine you work at a company, and then in your company you happen to have some sort of AI companion. Let's not talk about any brands in particular, just an AI companion. And let's say, I don't know, you work at a hospital as a developer, and you want to find out some information about a disease rate, and you ask your companion, like, tell me about this disease rate, and then you get information about the patients who got that disease, and that is an example of sensitive information disclosure. This is not only illegal and against any data protection laws, it's just not correct to happen. So that's when what we need to avoid happening. And one of the first or the main ways to avoid this from happening is by using authorization. So authorization defines who can do what. And I'm going to spend some time talking about authorization and different authorization systems in the context of maybe not necessarily AI, but I think if we think about it in the context of any human or like normal program, we can extrapolate that into an AI application as well. But yeah, often when we're talking about authorization, the first step is authentication. So authentication tells us the user is who they say they are, and then that's what we would say, okay, then you have access to the system if you are an authenticated user, if I know who you are. Now, in the same context of an AI application, and I think many non-AI applications, authentication is simply just not enough. You know, just you have a bunch of users that are allowed to do this, but maybe not all of them should do it. And if we think of the AI companion example, yes, let's say we still work at this hospital and okay, all the employees have access to it, still not enough. We have like a wide range of things that we can do that we shouldn't be doing. And so you can kind of refine your authorization a little bit more. And so now we're going to talk about role-based access control. So in any organization, and also in this fictional hospital that I'm talking about, we have the concept of roles. We have, I don't know, an IT admin who has access to some things, an HR person, and they all have different roles, and therefore should have access to different things. Now, in RBAC, role-based access control, we're assigning permissions to users based on their role within that organization. Now, if we think about the hospital thingy, we could have a role like data reader, and now those users that have the data reader role can perform certain actions. But then again, this might be sufficient for some use cases. It really depends on your use case. But in my example of the AI companion part, this is simply not enough. Again, we gotta refine a little bit more and be a little bit more granular in our permission schema, so to say. And so if we want to take it one step further, then we would go into attribute-based access control, also known as ABAC. And ABAC is all about assigning permissions to users based on assigned attributes of an entity in your system. For example, let's say you have an application and you want to grant permission based on the user's IP address because you want them to have access only from a certain location, I don't know, something like that. That would be using an attribute IP address to grant access. In my AI example, again, if I think about it, maybe I could grant, maybe I could grant access based on, let's say, the user's department, for example, and say, okay, if you are a developer, you shouldn't have access to this, but then if you are someone from, I don't know, a C-level, then you can see everything, probably. So then again, we get more granular and we are allowing ourselves to kind of define more nuanced rules in our authorization system. But still, we could even take it more granular and like a step forward, and that takes us to relationship-based access control, also known as a RBAC. So RBAC consists on assigning permissions to users based on the relations between the entities of your system. And the good thing about RBAC is that depending on how you define those relationships, you can implement roles and you can implement ABAC as well. So RBAC and ABAC as well. So for example, let's say we have a system like Google Drive or GitHub, for example, but let's talk about Google Drive. In Google Drive, you have the relation, a user is an owner of a document or a user is a member of a group, and then therefore they have access to this document. But you see, you have granularity in the sense of you are able to control to the level of the document, to the level of the attribute of the document, for how long do I want to give you access. So it gives you a lot of flexibility in a lot of granularity. Now, which one do you think is the best? Or which one do you think works the best? And I'm taking the opportunity because we're such a small group and we can, no? Okay. The answer to this one is my favorite answer to give to anyone asking me something, and that is that it depends. And it depends on the use case that you have. It depends on the resources that you have to implement an authorization system. It depends on your business needs. It depends on all sorts of things. For some users, RBAC might be enough, ABAC might be enough, or they might have to go to something like RBAC. So remember, with RBAC, we have roles. It's more familiar. It's kind of straightforward because you can migrate your organization structure into that. And it gives you some coarse access control. ABAC is based on attributes from entities in the system, and it's a bit more granular than RBAC. And then we have RBAC that is based on relationships and gives us finer access control. And now to answer the question, which authorization system works best, I could have probably rephrased that to which one works best for the AI example that I was talking about. We're going to say that it's RBAC. And, oh, I did change that, but I just did it in the other slide. So for an AI application, the one that could work the best would be something like RBAC, but with a little bit of a twist. And that twist is called Fine-Grained Authorization. Now, if you looked at the title of this talk, it said something about FGA. That's what Fine-Grained Authorization stands for. FGA stands for. And it's basically a RBAC implementation. And the whole point of it is that you can allow users to access your resources based on the relationships, and it has a little bit more to it. One implementation of fine-grained authorization is actually called OpenFGA. So OpenFGA is an open source authorization service that allows you to perform authorization checks to literally define this user has access to this object based on this relation. And when you implement like a good FGA system, it's very much scalable in the sense that it allows you to grant or verify user access regardless of how many millions of objects and users you have. And there are mainly three important things that we need to know about FGA. So we have stores, authorization models, and relationship tuples. So a store in OpenFGA is where you would save your authorization model and your relationship tuples. So it's basically where you store the data. Then the authorization model would refer to where you define who can do what and under which conditions, meaning that's where you would define the rules of your authorization system. Then we have relationship tuples, which can be tuples or triples, and that's where you define this user has this relation with this object, and they're kind of like the facts of your authorization system. And then also you can interact with OpenFGA via the API. It's a REST API, and then you can make checks, and that would be kind of like the main endpoint, because that's the endpoint that is actually going to take, say, this user has access to this object, or has this relation to this object, actually. And then you can, for example, list the objects that are related to a user, or list the users that are related to an object, and so on and so forth. If you were to play around with OpenFGA, this is more or less what you would find. This is the playground, and so this is a test store. You can see it on the top left there. And on the left, I also have an authorization model where I've defined two types. I have a type user and a type doc. And the type doc has two relations, one's owner, one's viewer. And those relations can be assigned to users. I'm going to dig a little bit deeper later, but I just wanted to give you an overview of how the playground looks like. Then below on the left side, we have tuples. I created a tuple that says the user Carla is an owner of the doc roadmap, and then user Anne is a viewer of the doc roadmap. And then on the right side, you have like a graph view of your authorization model. Now, back to the AI example and how to secure AI applications and whatnot, I thought I would show you this with a use case. So let's think about a RAG-based assistant. So RAG stands for Retrieval Augmented Generation. Thank you. I was just testing you. No, I'm just kidding. And it's basically giving more context to an LLM, so it gives you better answers, right? But I have an example in Python. If you don't know Python, that's okay, because I want to show you mainly just the workflow of the thing, more than the syntax and the code itself, because this is a simple example. But let's take a look. So in this case, we were building a RAG application where users can see the forecast of a certain company. So in this case, what we would want to do is that the user, John Doe, in this case, is asking a question, show me the forecast for a company named Seco. And yes. And then we would run a semantic search. We're going to query the vector store and get relevant documentation for that. I'm using the OpenAI SDK to make the query and all that stuff. And then we're going to filter those documentation based on the user permissions. And this is where I'm going to be using OpenFGA, in particular the Python SDK, to enforce those authorization rules. And then finally, we're going to answer to the question you see only the relevant docs. So FGA is going to filter out whatever you can't see, and then we answer the question only with the information that you can see. Therefore, kind of like avoiding the sensitive information disclosure part. All right, so remember the authorization model where you defined who can do what? This is what an authorization model would look like for this particular example. So in this case, you have the model schema 1.1. That's just the version that we have right now. Then we have two types, user and doc. Doc has two relations where we're saying the relation owner can only be assigned to a user, and the relation viewer can only be assigned to a user as well, a single user, but it can also be assigned to any user. So this syntax with the colon and star is a way to say of like anyone can see these. All right. Again, if we take this information into the playground, it kind of looks to what I already showed you before. The only difference is that the tuples are different just because to keep it consistent with the example, I named the docs doc private and doc private, I guess. But yeah, we have public documents and private documents, and that's how we're going to define this example. So basically, if a document is private, no one can view it. That's the rule that we're going to define for our system. All right, so how does this look like in Python? Hopefully it's readable. This is literally the main.py file, so this is just the application workflow. Like I said, this is a simple example. So the first thing is we're initializing this, and then we are going to create a local vector store. We're going to use a local vector store class. It's a custom class that we created. That's where the whole OpenAI SDK interaction is happening, which I'm not going to go deep into because not the point of this talk. But yeah, that's where that's happening. We're basically loading private and public documents into our database, and then we're going to use that local vector store to perform the search, for example. We're going to search using the OpenAI SDK, and then we're going to convert the search results into documents with store. This is just another way for us to define how good of a result is this document. So I think right now we're using a distance of 2. And now the part that I'm more interested about, it's right here. That's where we're going to be using or interacting with the OpenFGA SDK. So we call this class the FGA retriever, and as you can see, we're going to pass the documents, and we're going to build the query. And the query that we want to answer in this case is this user, does the user, whatever we're passing, has a relation viewer with these documents? And so we're going to go into the FGA retriever now. And as you can see, I'm importing the OpenFGA SDK in Python here using I'm going to use some client configuration, credential configuration, and whatnot. And then I am going to initialize the client here. Now, for reference, if you see Auth0 FGA, blah, 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 Auth0 has a hosted version of OpenFGA that I was using. You can just run OpenFGA in your local machine, in your own server, and then replace that information there, like the API URL and the credentials and whatnot. You can customize it as you need it. So we initialize that, and then we're gonna check the permissions. So for checking the permissions, what we're gonna use is an endpoint that OpenFGA has that is called a batch check. And the batch check allows you to literally ask, does this user has this relation with all of these objects? And so that allows you to make just only one request for a bunch of objects and just have a better performance overall. So we're gonna just pass the documents and do that, and then we are going to retrieve those documents. And the retrieve document, now that I'm looking at this, I should have probably twisted them. No, so first the retrieve and then the check permissions, because check permissions is being used there. But yeah, that's basically what this code is doing. So once we get those documents back, and now we are only getting the documents that that user is a viewer of, we go back to our main.py, and that's when we're gonna generate an answer only based on those documents. Now, this is an example a colleague of mine wrote, and you can learn more about it in this blog post. Also, if you want to take a look at the different examples, code examples that are out there using OpenFGA and AI stuff, you can go ahead to this repo or auth0.to/auth0 AI samples. And finally, if you want to learn more about OpenFGA and just test it out, run it in your local machine, it's a Docker image, so you can just go ahead and do it. You feel free to go to openfga.dev or just follow the QR code. And yeah, to answer the initial question of this talk, which was, so do we need an OpenFGA? My favorite answer is that it depends. So thank you very much for coming. I can take questions if you want.
So this is an implementation of RBAC then?
Yes, it's actually something I forgot to mention. It's so OpenFGA is inspired by Zanzibar, which is Google's internal authorization system. But yeah, it's an implementation of RBAC, correct. All right, well, thank you very much and have a great day.